Let's begin our discussion of partial derivatives with a reminder of taking derivatives in general using the power rule. If we have the function 3x, the first derivative with respect to x is 3. If your function was y equals 17x, the first derivative with respect to x is 17. If your function is y equals x, your first derivative with respect is just 1. So the coefficient of that linear term. Now what happens if we have another piece within this term where it's not only 3, let's say 3ax, where a is a number or a constant. Then the derivative of that is 3a, and the derivative of the x is the 1. Remember, the power rule says this exponent is a 1. Bring the exponent down, multiply it by the coefficient, which is 3a in this case. Subtract 1 from the exponent is 0. X to the 0 is 1. And so you just get that coefficient. Now, what's happening when we take a look then at functions of x and y? Somehow we're forgetting this idea of a coefficient of a linear term, that the derivative is that coefficient. And remember, the derivative, first derivative, is the slope of the tangent line, and this is just a line. It's got slope of 3a, and so it makes sense that its derivative is 3a because it is a line. Let's look at a function of two variables, x and y, x squared, y squared, plus e to the x, y squared. Let's take the first derivative with respect to x, and when you do that, we are holding anything else that is not an x a constant. For us, in this term, we have an x and a y. The x is the variable, the y is the constant piece, so you could go ahead and box that and say, well, that's really like my coefficient, and when I take the derivative, that's going to come along for the ride. When you take a look at the next term, it's an exponential, so we're going to write it as it is and then chain rule out the derivative of that exponent. So let's do this one term at a time. The first term here, the y squared coefficient comes along for the ride. Derivative of x squared is 2x, so that gives us 2xy squared. Simplify that. The derivative of the next term, exponential, we write it as it is, 2xy squared, and now we have to chain rule out the derivative of that exponent. But taking the derivative, it's the derivative with respect to x. So again, that's a coefficient. The derivative of a linear variable, because this variable has an exponent of 1, the derivative of a linear variable is just its coefficient. So if y squared was 17 instead, and we had 17x here, we would say the derivative of 17x is 17. Instead, we look at it and say we have a derivative here, a coefficient, and a linear term, so the derivative of that is just its coefficient, which is y squared. Let's go ahead and rewrite that, and we get y squared e to the x y squared. Let's do logarithm. We have a function, f of xy, and 3x plus 2y plus the natural log of x plus y. Let's take the derivative with respect to x, which means the y is a constant. Do it term by term. Derivative with respect to x of this first term is 3. The derivative of the second term, y is a constant, as if this was 2 times 17 or 34. The derivative of 34 with respect to anything is just 0 because it's a constant. But we do have a y here, so we're still calling this a constant. The derivative of that is 0. Plus the derivative then, a logarithm. And inside that logarithm is a variable. So this term has a variable in it, so we're going to have a derivative for that term. Even though the y is a constant, it still has an x inside. So the derivative is 1 over what's inside, and then chain rule out the derivative of what's inside. Now we have to look at it with respect to our x as a variable, y as a constant. The derivative of x is 1, and the derivative of y, since it's a constant, is just 0, so it's plus 0. Simplify that, you get 3 plus 1 over x plus y. Let's go ahead and take the derivative of that function with respect to y now. We can box this. This is f sub x. Let's find f sub y, which is the derivative with respect to y. The first term has an x in it. X is a constant or a number. The derivative of a number or constant is 0. So this starts out with 0. The next term, 2y. Y is the variable, so what is the derivative of 2y with respect to y? It's 2. Next and last term, natural log of x plus y. Inside there, the x is a constant, the y is a variable, so this is a term that has a variable in it, so we need a derivative. The derivative of a logarithm is 1 over what's inside, so 1 over x plus y, and then chain rule out the derivative of what's inside. So the derivative of x plus y with respect to y. X is a number. The derivative of a number or constant is 0. And then the derivative of y is 1. So we can simplify that to say 2 plus 1 over x plus y. And that is the partial derivative with respect to y. If you're still having trouble with these, I recommend that you try the study plan on MyLabs Plus for this section, and then come and see me during office hours as well. Hope you're having a great day.